Okay. All right, YouTube, I think we got some sound now. Oh, can you fix that? There we go. Yep.
Great.
Okay. All right. So, YouTube, you guys should have sound now. So everybody should be able to hear me now. Lovely. So, let's see. Oops. All right, so those of you who are just joining me, my name is Sarah, and I sit here and I do, well, right now, since we're on summer break, we do primarily SAT problems, but we focus on math problems, primarily through like pre-algebra through algebra 2, kind of into pre-calculus. During the school year, we really get into like ask me anything, like what do you want to talk about? I'll, reteach and all of that. But for right now, we just kind of, because we're on summer break, SAT, it's never too late or too early to start preparing. So might as well. All right, so let's take a look at this. There's a lot of different ways to solve this. Now, when I'm explaining these, I am not going for the most efficient explanation, right? I'm not going for the most efficient way to answer this problem. Sometimes we'll kind of talk about that, but we're also kind of going into like how you solve this problem, why you solve this problem, like those types of things. So sometimes my explanations get a little long-winded. This may or may not be what you do on the SAT or any sort of standardized test. Okay, so we've got if 4x plus 2 equals 12, what is the value of 16x plus 8? So one way that I could go about this is I could solve for x, right? I could do, let's see, I've got 4x plus 2 equals 12. So I could subtract 2, Then I've got 4x equals 10. So x equals 10 over 4, which is 5 over 2, which is 2.5. And then I could plug that into 16 times 2.5 plus 8. Okay, I could solve for x and then substitute. But what I can also do is what I might be able to notice is that, because working with 2.5 is kind of ugh. But what I may also notice is that 16x plus 8 is 4x plus 2 if I multiplied it by 4. So if I have 4x plus 2 equals 12, okay, and I'm trying to figure out 16x plus 8, if I multiply this by 4, that gives me the 16x plus 8. But I can't just multiply one side, I've got to multiply both sides. So then I would multiply this side and I would get 48. So my answer for this one is B. Okay, but again, you could absolutely solve for x and then substitute in, especially if you have a calculator, right? You can just use the decimal 2.5 and it's going to be great. Okay. So Barbara on YouTube, the 11 plus maths. I'm not sure. What country are you from? Because 11 plus maths, I'm assuming is I'm assuming is like in high school, right? Okay, so let's do. Let's do this one. Okay, we got a little bit of exponent rules. Yeah, so it works for the problems with these problems. Let's see, Ruby, you're saying, so that works for all problems just like that example. I mean, yes, as long as it will, as long as you can kind of multiply it to make that new expression, right? So that one, because it was 4x plus 2 times 4 was 16x plus 8, it's just kind of looking for that pattern, right? Okay, so Barbara, let's see, in year 6. Oh, okay, so the 11 plus is for age. So you're like 11 years old and up. So that one may not have been in year 6. So a lot of these are usually more into like year 10 or year 11. That's where we're going into with this. This is an exam that's pretty standard in the United States and for like United States colleges and universities. It's like an admissions test sort of. Yeah. Okay, let's see. All right, so let's take a look at this one. Okay, so let me zoom it out a little bit. There, Trish, let me know if that's better. Okay. Okay. And we got a lot of people saying B, maybe D. All right, I'll give you guys another minute or two and then we'll start jumping in and going on it, going through it. A lot of B question mark. Exponents can be really tricky. Yeah, so Trish, we'll get into a little bit of exponent rules with this one. Okay. So we've got somebody asking what type of math this is. So this is from the SAT, this is primarily given to high school students towards their like 11th and 12th grade year. But this in particular, these exponent rules are something that you probably start to learn in middle school. Like 6th and 7th grade, you start to learn the exponent rules. But you probably won't necessarily see negative exponents until you get into algebra, but really it just kind of depends. And like exponent rules, the thing is that the exponent rules never go away, but they also never change. So you don't really have to worry about them changing on you, okay? Okay. So Jake from Produce, anyone in the community that does log function videos? There is somebody, I'll have to look up their name, that does calculus videos more frequently. Sometimes we'll get into logs on my live streams during the school year. So like starting in August, later August and September. Okay, let's lock in our final answers. So Jackie, this is from, I believe this is from module 1, which is the part that's a little bit easier. Okay, all right, so let's look at these exponents, okay? So with any exponents, if you forget the exponent rules, that's totally fine as long as you understand what exponents are, right? So multiplying things together by themselves, that's what you get with an exponent, right? So if I have something like x squared, that is x times x. I multiply it by itself 2 times, okay? So when I'm multiplying all of these together, when I look at all of this, everything is being multiplied together. Since everything is being multiplied together, I can actually just change the order, whatever I want to, whatever I need it to be, right? So what I'm doing is I'm going to be kind of like simplifying it down so I just have one of the M's, one of the Q's, one of the Z's, okay? So if I've got 4 M's being multiplied here and 1 M being multiplied there, that means I'm actually multiplying 5 M's together. So it's M to the 5th. Now, that right there is enough for me to say, okay, then the answer has to be B, right? Because B is the only one that has M to the 5th. Now with that, I can just, boop, move on. Okay, if I were in the actual SAT or something like that, I would probably just sort of say like, oh, well, M to the 5th, the only one that's there is B. Okay, but let's take this opportunity to just double check. So we've got q to the 4th and q to the 9th, right? So how many q's are we actually multiplying together? We've got 9. And then, so the pattern becomes that if I'm multiplying things together like powers, okay, I'm gonna add those powers together, okay? So 4 plus 5 is 9. Now that pattern never changes, right? So if I've got z to the -1 and z to the 3rd, even if I don't realize what that z to the -1 actually means, okay, I'm still going to add those together. I'm gonna get z to the 2, z squared. Okay, now one note, so the answer would be B. There's the answer, B. Okay, now one note is that z to the -1 power, a negative power actually drops it down to be, it kind of like flips it, right? So it makes it like the reciprocal. Okay, so z to the -1 is actually 1 over z. So if I've got z to the -1 times z to the 3rd, I could also look at this or think about this. And somebody asked earlier, I think Trish asked earlier about the division piece, right? So when you're dividing exponents. So if we think about what the -1 actually is, where it drops it down below, okay? So this gets into, now I've got z to the 3rd on top over z on the bottom. So when you're dividing powers together, okay, we can think of this as z times z, whoops, times z over z. One of those is going to cancel out. So all you're left with is this, which is z squared. Okay, so when you're dividing exponents like this, you subtract them, and this is why. Okay, so again, when I've got a negative exponent, it's going to drop it down into the reciprocal. So there's a lot of different ways to think about this, right? So this is going to be z squared. Again, does this really matter for this question in particular? No, not really. But will it matter on another question about exponent rules? Yeah, maybe, okay? So there we go. So the answer for that one is B, okay? All right. Let's do this one. Zoom it out a little bit so you guys can see it. Okay. Okay, so again, if you're just joining us, this is from the SAT bundle number 10, I believe. The SAT is an aptitude test that colleges and universities will use as like not really an acceptance, but just sort of like an entrance exam kind of. So you can get these bundles. These are all just from the College Board website. So you go to, I think it's just collegeboard.org or .com, I'm not sure. But if you just look up College Board, and they'll give you PDFs of practice exams. So what I've been doing with these is I just download these different bundles and I pick a couple of pages and we go through them. So it's really good practice. I know that the SAT is primarily moving over to being a digital exam, which changes things a little bit because it's more of a dynamic test. But we've got this is still good practice for like the concepts and the question styles and things like that. Okay. All right. Ooh, we got a little discussion going on in the chat. Okay, so it seems like most everybody's going between B and A, right? Okay, so there's 2 bits of important information that will get us the answer in this. Okay. We've got that this airplane descends and constant rate. Okay. Descending means that it's decreasing, so that takes out C and D. Okay, so it descends from an altitude of 9,500 to 5,000 feet. Okay, the constant rate means that it is a linear descent. Okay, it's going from 9,500 down to 5,000. Okay, now somebody in earlier was saying like, well, but eventually it's going to stop. Okay, but it's not going to stop at 5,000 feet, right? It's going from, it's got that linear thing. So it's just like, I mean, so think about this, right? If you're talking about, well, I drove my car for 3 miles at a constant rate of 50 miles an hour, right? That between those two ending points, it's gonna be a constant rate, right? I've got cruise control set. Now, before that, I had to speed up. And after that, I may have to slow down. But in that section, it's a finite part. So if I were looking at this graph, it might look more like a piecewise function, right? Where it's going to be a linear part. And then it might be like if I were going in for a landing, right? I might be doing more of like an exponential descending because I am kind of moving and then I'm going to kind of like slow down my descent, right? All of that. But this is just talking about between 9,500 and 5,000. So in this case, don't overthink it too much. Just go with what they tell you, okay? It's a descent and it's constant. That's decreasing linear. Okay. All right, let's see. Okay, so this, and also, remember, it's best. Okay, it's the best model. The best model we have out of these four is decreasing linear. Okay, if the situation were different, if we were relying on actual information or the actual like graph of like with wind resistance and all of that kind of stuff, sure, it may be more of exponential, but in this specific case, it's saying it's descending at a constant rate between these two altitudes. It's decreasing linear. Okay. All right. Okay, let's see. Okay, let's take a look at, let's do a system of equations. Let's do this one. Okay. Thanks, Braden. I love that I'm doing this too. Yeah. All right, guys, so take a look at these. Okay. Yeah, so Chucks, that's great that you used Desmos. You can absolutely use Desmos to solve these. And when you're doing the SAT, it does let you do that. Like the Desmos calculator is built into it if you're doing it through, I think it's Blue Book is the app that they use. Okay. Yeah, it's Blue Book. Okay, thanks, Chucks. Mac, what grade do I teach? I teach primarily 10th grade, but I also teach, I mean, some freshmen, some juniors, but primarily high school. But I have taught all through, I mean, really, I've taught like kindergarten through 12th grade over the years of teaching. But for math, I've taught middle school through 12th grade. Okay. Oh, so goat curry. So you asked, what did I get on the SAT, or you don't take, just teach. So I took the SAT, I mean, a really long time ago. And I got 13 or 14 something. But yeah, so now primarily I just teach it. I haven't taken it in a while, other than like, so when I'm working these problems out, I don't actually look at these problems. I don't have the answer key or anything. So when I'm working them out, I'm working them out with you guys. So I'm figuring it out with you. So you get to see me figure this out in real time. So it feels like I take the SAT all the time. Okay. Royale over on YouTube is saying, do you teach in the US? I do. I'm teaching in Michigan. Okay. Some other SAT. So Zach, let's see. Some other SAT prep tutors take the actual test. I should probably just take the test, like sit down and take the test at some point. But I do so many practice problems with this and with my students and everything. But yeah, maybe I'll just, that'd be a funny live stream. Just watch me take the test the whole time. I know, Logan, I'm kind of like, maybe, maybe not, probably not. Okay, so let's take a look at this one. So this is one that's not multiple choice because there are still problems on the SAT that are not multiple choice. They're the free response or the open response. So we've got the solution of the given system of equations is x comma y. What is the value of y? So this one is pretty straightforward if you're familiar with systems of equations. But if you're not familiar with systems of equations, this one can be really weird and challenging, okay? Because a lot of times when students are taking this and a question like this shows up and they're a freshman or even in 8th grade taking the SAT, they haven't really learned systems of equations yet. It can be really confusing. So when you're looking at this, the solution to a system of equations is x comma y. What that means is that you've got these two equations and you've got a value for x and y that solve both equations. Okay. The way that this looks on a graph is you've got two lines and they intersect, and where they intersect, that is their solution. Okay. So in order to figure this out, there's a lot of different ways that you can do this. There's substitution, there's elimination, those are the two main ways. You can graph it. So you can use Desmos to graph this, but I'm going to use elimination because I see that 3x and 3x are there. So because the x and y values are going to be equivalent, okay, because these x and y values are the same, I can actually mush these two equations together, okay? So I can't do it for every single equation, right? Every single system of equations. I can't, well, I mean, you can mush them together. Anytime you're solving a system of equations, you can mush them together. And mushing them together is also called elimination. Okay, so the way I'm gonna mush these together is by adding or subtracting in a way that's gonna get rid of one of the variables. Okay, now, if I subtract these, okay, I've got 3x minus 3x, that's gonna go away, because that's 0, right? 3x minus 3x is 0. 6 minus 4 gives me 2. 4y minus 2y gives me 2y. So now I know that 2 equals 2y, so y equals 1. And lucky for me, they were asking me what the value of y was. It's 1. Now I can go back through and I can plug this in to figure out what my value for x is going to be, but it doesn't really matter, right? I don't need to know. So in this case, I can just move on, right? I would put 1 down and I would move on, okay? Let's see. All right. Oh, the chat is going off. Okay. Okay, let's see. All right, let's do, oh, that was the last page that I picked. Okay, so those were questions from module 1, which are kind of the, a little bit easier Okay, let's do this one. Okay. Hmm. So this one, if you guys are asking for a little bit more challenging, here we go. So I'll show you guys how to work this out, kind of the math teacher way, but then I'll also show you how to work it out or how to figure it out if you have no idea what to do, okay? So Mathematic Fanatic, I primarily kind of stop at about Algebra 2, getting into trig. That's the highest level of math that I usually accept tutoring clients. Cool teach. Okay, you'd graph the given function and graph each option to see which one matches. Okay, that's an interesting way of going about it. Okay. Okay, so I can't really see what that is. Sally? I don't know. I can't read what your full name is. Let's see. I have an engineering degree and I want to teach math in high school. I found out I forgot most. Yeah, when you go into those really high up maths, a lot of times, yeah, you forget things like how to find the area of a triangle, right? But it's really nice kind of revisiting these things and knowing where you're going and like what you're preparing your students for. So I think a lot of the best, especially math teachers, are maybe coming from an outside career. They had a career first and then came to teaching. I think a lot of times that's really beneficial. Okay, so let's see. So Batman X Wayne says, what kind of math is this? So this is directly from the SAT. Now this particular math, I would say this is Algebra 2. I would say that this idea is Algebra 2, where you've got these complex numbers and where you're doing a lot of different things like that. Okay. So let's look at this the math teacher way. Okay. So I've got answers all over the place. Is it E, Troy? There's no E. Yeah, whoever keeps asking for triple integrals, Taro, so right now tonight we're focusing on the SAT problems that we have. Triple integrals, that's kind of beyond things that we really focus on here. We really only go up to like Algebra 2. Okay. Okay, so let's get into this. So math teacher way of answering this question. Okay, I'm gonna factor. So I look at this top part and I've got 8x times x minus 7 minus 3 times x minus 7. So I can actually factor that out and I've got 8x minus 3 times x minus 7 over, now I can also factor this, right? I can take out a 2 and I'm left with x minus 7. The x minus 7s cancel out. So what you're left with is 8x minus 3 over 2. So the answer is B. Okay. Goat Curry, you do not need to know integrals for the SAT. Nope. You do not need to. You're going to be fine if you're in Algebra 1 in 11th grade. You're going to be fine. Okay? All right, so with this is just factoring. You're canceling things out. There you go, 8x minus 3 over 2. That is the math teacher way of solving this. Now, if you go, I have no idea, okay? I mean, if it's one problem, like you can just kind of skip it. That's probably not the best math teacher advice. But I also feel like, I mean, if you just go, pooh, I have no idea. Blindly guessing one problem is not going to completely tank your score. Okay? Now, blindly guessing multiple problems, that's gonna not great. But if there's one, so everybody's kind of getting hung up on this x is greater than 7. The reason they're saying x is greater than 7 is because of this bottom piece, which is 2x minus 14. 2x minus 14, the x has to be greater than 7 because if it were 7, it is going to be 0, right? 2 times 7 is 14, 14 minus 14 is 0, so you can't be 0, right? It can't be 0 in the denominator. That's the primary reason why they're saying that x is greater than 7, okay? Now, so that is the math teacher way of solving it, is just factoring, cancel out factors, move on, okay? Now, another way that you could do this is not the math teacher way, but if you feel like you've been guessing a lot, here's one strategy, okay? So I've got a couple different strategies that you use on the SAT, which is you can like solve the problem and find your answer, right? So that's what we did here, right? We solved the problem and we found the answer. The other option is where you can use the answers to figure out, or use your kind of options to figure out the answer, okay? And in that case, what I would say to do is pick a value that's greater than 7. So maybe do x equals 8. And then what you can do with that is you can plug in 8 for every value of x in here on your calculator. Now be careful with using like parentheses and all of that, and see which one of these, when x is 8, equals it. Okay? You can do that too. Now that's pretty time consuming, right? But it's sort of like, I think somebody earlier had said, well, what about, graphing them all? Sure, but it is gonna be time consuming. Okay, it would be very time consuming to go through and plug these all in, unless you're really quick with your calculator, because once you figure out what this initial value would be, I mean, then like x minus 7 over 5, you can figure that out in your head, or pretty close, right? So that would be 1/5, right? If this original is not 1/5, then it's not A, right? B, you'll end up with the same answer, so then you can figure that out and move on. Okay, these two down here are very time consuming to try to figure out. Okay, that would be the same as if you kind of foiled those together on the top. Okay, all right. Okay. Ooh, hand hearts. Thank you, Impact Math Teacher. All right, let's go into another one. Okay. Let's see. Okay. Let's take a look at this one. Okay, we got some circles on here. Okay, so Rain Benson, let's see, you're saying group theory is algebra. Let me scroll up so I can see what that was that you were talking about. Okay, so oh, I see. Okay, so yeah, so Rain, you're saying that group theory is algebra. True, it is. It is a branch of algebra, but it's a little more advanced. Yeah, it's not. Yeah, it's from abstract algebra. It's not going to be on the SAT. So the SAT is pretty straightforward. Algebra 1, Algebra 2, geometry, but it's mostly Algebra 1 and Algebra 2. Ooh, Rain, you're getting your degree in math. Awesome. That's exciting. Rocket science is now on the SAT. Ooh. Okay. So ACT, so user 228 something. So the ACT is very similar. So these are just SAT PDF problems because they're available. The College Board puts out a lot of PDF problems, problem packets. So we're primarily doing the SAT on here, but the ACT is very similar. The ACT is similar test structure insofar as like content level and things like that. But yeah, okay. Oh, Kayak, you're doing AP Pre-Calc and AP Stats together. Oh, you better warm up that calculator. That's going to be a lot, but that's exciting. Okay. Barbara on YouTube. So in a couple of weeks, we'll start doing some math lives that are that will include pre-algebra, and a lot of this stuff is pre-algebra also. Okay, guys, let's lock in your answers for this one. Okay, so for this circle question, let's lock in your final answers. Okay. This is one of those ones that goes really, it gives you a lot of information that you do not need. Okay. Okay, so what we're really looking for is the key pieces here is you've got a diameter with these endpoints, and then R is a positive constant, and what is the value of R? Okay, now so even if I didn't know what the equation of a circle was, I could still probably figure this out or make a pretty good guess at it. Okay, if I've got a diameter that ends at 2, 4, and 2, 14. Okay, so I've got this diameter. Okay, and I've got it at 2, 4. Oh, this is too far. I'll move it up in just a minute. And 2, 14. Okay. The length of this line segment is 10. All right, so 10 units. That is the diameter of the circle. Okay, now the diameter means, or a diameter of the circle means that this is going to be the center point. Okay, and that means that it's going to be 5 and 5. Now these distances from the center to the sides is the radius. So the radius for this circle is 5. Okay, now with the equation, it doesn't really matter what the equation is. Okay. Okay. Yes, it should be a vertical line, but that's going to be really difficult to demonstrate. So what you're really looking at is the 4 to the 14. Okay. So when you've got this radius is 5, that would be your answer. Okay. There we go. Okay. This one is it's pretty straightforward as long as you don't get thrown off by the information, right, that you're being given. Okay, let's check out this one. So we've got a couple of lines going on. So Trish, you could solve that last one. Well, actually, you could if you substituted in one of the endpoints. If you substituted in the 2,4 or the 2,14 for the x and the y values, you could solve it with the equation. Sure. So Isabella, this is from module 2. So this is from module 2. So typically when we've got, there's two major sections. Well, there's module 1 and module 2 for the math portion of the SAT. So those of you who may have taken the SAT previously, there used to be a section where it was no calculator, and then there was a section with the calculator. They've done away with that. So now you can use your calculator no matter what. No matter which section that you're on. And they also, when you're taking it online, they also let you use a Desmos calculator. Okay, let's see. So Jojo, I do use Desmos. It's not my favorite thing to use. It's not my favorite calculator to use, but I know it is kind of nice to be able to like look at the different graphs and things like that. And Desmos is the calculator that they do provide on the SAT when you take it online. But Desmos is not my favorite to use, but it's fine. That's fine. Okay. All right, so lock in your final answers. Got lots of 4s. We've got lots of 1/4s. Okay. Ooh, lots of little gifts coming in. Thanks. Every little bit helps. Yeah, so, and Zach, it's not necessarily the negative reciprocal, but it's the opposite reciprocal. Okay, so if it were already negative, it would be changed to positive. Thank you. Okay, so line L is defined by 3y plus 12x equals 5. Line N is perpendicular to line L in the xy plane. What is the slope of line N? So the slope, so perpendicular means they intersect at a 90-degree angle. So perpendicular lines have opposite and reciprocal. Oh, that word looks weird. Reciprocal slopes. Okay. So opposite means positive or negative, right? So it's positive or negative. And reciprocal is where you flip. So A over B becomes B over A. That's reciprocal. Okay. So in order to figure out what my perpendicular slope is, I need to figure out what my original line slope is. So 3y plus 12x equals 5. I'm going to go ahead and I'm going to solve I've got to figure out the slope of this line. The easiest way to do that is to get y by itself. Whoops. Okay, to rewrite this into slope-intercept form. So I'm going to subtract 12x from both sides. And I've got, so that gives me 3y equals negative 12x plus 5. And then I'm going to divide everything by 3, which gives me y equals negative 4x plus 5 over 3. So what that means is that my slope, my original slope is negative 4. So my opposite would be positive and my reciprocal would be 1/4. Okay. Negative reciprocal of a negative becomes positive anyway, so I teach it as negative reciprocal. So what I have found, though, H, is that saying opposite reciprocal, at least for my students in my experience, has been a little bit easier, because if you say it's negative reciprocal, a lot of times students just assume that it's always going to be a negative slope. But either way, I mean, either way works, right? Okay, so that would be 1/4. So my opposite and reciprocal slope would be 1/4. Ta-da! All right, let's see. We got time for one more. Let's see. Oh, let's do this. Well, we might actually, this one will be pretty quick. Okay. So Braden, the answer was 1/4. So I don't see what you wrote down, but yeah, that's 1/4. Positive 1/4. All right, so we've got this function notation here. So go ahead and pop your answers in the chat. And this one, I believe, is back from Module 1. It's a little more straightforward. Ooh, look at all those answers coming in. I'm gonna give you guys like one more minute because... All right, Michael Ari, final answer. Okay, so this is a really good demonstration of just basic function notation, which means that when you have this function notation, this x, whatever's in those parentheses, that's what gets substituted in here and here. Okay, so f of 2, I'm going to substitute in that 2 for any of my x's. So 2 squared plus 2 plus 71. So 2 squared is 4 plus 2 plus 71. So f of 2 is 4 plus 2 is 6. 6 plus 71 is 77. Okay, and that is basic, straightforward function notation. Okay, so f of 2 is 77 because you just substitute in whatever's in the parentheses goes in for those x's. Okay. But Brayden, so you completely forgot how to do that, but now do you remember it? Hopefully. Well, that's good that you're joining now. Okay, let's see. All right, let's do one little geometry. I feel like I did this problem. Huh. There was a very similar problem with this one that we did last week. Very similar. Cheesecake, when are your next live? So I'm live every Thursday. Sometimes I go, usually we're like now 8 to 9, at least Eastern time, I guess. But sometimes we'll go earlier in the day, especially since it's summer break. But once the school year really gets into full swing, so like certainly after Labor Day, but even like the week before, I'll be from 8 to 9 Eastern every Thursday, and that'll be more of like an Ask Me Anything. So I don't necessarily do SAT, but I'll take questions from the chats and all of that, and so we go live. And you can also, I also do virtual tutoring and teaching classes and things like that. So, you know, click the link and do the stuff. Okay, so congruent. A couple of people have asked for congruent. Okay, so congruent means equal. Same shape, same size. All right, so we've got triangles A, B, C, and D, E, F are congruent, where A corresponds to D and B and E are right angles. So what that means is we've got two congruent triangles. Let's see if I can make these congruent. Yeah, pretty close. Okay, so B and E are the right angles. I know these aren't perfect, but deal with it. Okay, so A, B, C. So A corresponds to D, which means that they're in the same location. Okay, so in this case, I put them up at top. Did I draw this to scale? No, you saw me just draw it. I didn't use a protractor. These are right triangles because I say they're right triangles, right? A and D are congruent because I say they're congruent. Okay, so I know that A and D are congruent because they correspond with each other. And it's C, what is it? It's CP, corresponding parts in congruent triangles are congruent, something like that. Corresponding parts in congruent triangles are congruent. Something like that. Oh, okay. I think is it CPOC? It's CPCTC, I think. Ugh, I hate that. Anyway, but basically like the corresponding parts of a triangle are congruent, okay? Yeah, it's CPCTC, right? Okay. Corresponding parts of congruent triangles are congruent. I think that's what it is. Thanks, new SAT website. You do too. Okay. All right. So A and D. So the measure of angle A is 18 degrees, which means the corresponding parts are congruent. That means that D is 18 degrees also. Okay. Now the reason they tell you that B and E are 90 is so you know that A and C need to add up to 90 and D and F need to add up to 90 because all triangles add up to 180. So what I would do is I would do 90 minus 18, which is going to give me 72. So angle F and angle C correspond and they're congruent. So that is going to be 72 degrees, which is B. Okay. Excellent. All right, guys. Great work tonight. Awesome job. Have a wonderful night, and I will see you guys again for next week's Math Thursday. I agree, kayak math is so cool. Keep doing math every day. Come join me again. All right. Danny, where did I get 90 from? Well, because E is 90. So that means that these two need to add up to 90 also, because in a triangle, it's all going to add up to 180. All right, guys. Bye.